So I think it is recording, right? So okay, welcome you all. Today is our ninth lecture. So we will solve assignment 6 and 7 today and try to finish both the assignment. Then let's see how many questions we will able to solve. So let's start from question number 1 of assignment 6. So first tell me you guys are able to listen to me. Am I audible to you guys? Patlika and Shivam Mathur, and also my screen, tell me that my screen is visible or not. Fine sir, okay, all good, okay, nice. So our first assignment is, so first question is, matrix element behave like a set of orthonormal vectors for. So so great orthogonality theorem to solve the irreducible representation. So this is a Kronecker delta. So the matrix element behave like a set of the orthonormal vectors for. So this should be the irreversible, irreducible, but not reducible representation. So this should be the answer, as we know from this great orthogonality theorem. Answer is C. Reducible as well as no, no, no. I think it is wrong. I think it is wrong. But I will try to um, tell you in the next class if this answer is right or no. So according to me, answer should be B. So second question is, if order of group is H and dimensionality of one of its representation is Li, then the normalization constant of the vector in question 1 are normalized to. So this should be the answer. This one, because this is your normalization constant. So okay, the answer is also given D. So we are correct. So let's move to the next question. Question number 3 saying number of reducible representation in a group is equal to. So number of irreducible representation in a group is equal to the number of classes of symmetry of operation. So answer So the answer of this question should be option B. This we know, right? Okay. The fourth question is, a one-dimensional representation can never have character with value of. So this we need to little bit solve. One-dimensional representation means this. Let's see this. This is your one-dimensional representation. So one-dimensional representation can never have character with a value of. So question is saying that so a minus 1, 0 or omega. Out of all, out of these four, which one is which one can never have the character value? So which means that it cannot change your basis. So so for this one, if your one dimensional representation is this one, then the basis we have already know that let's say this is your transformation matrix, right? These are your bases. Let's say these are coordinates are your bases. Then they will change to new bases. So we were talking about this, these, this. So which one is possible? Can never have character here. So here already it is saying that this is one dimensional representation can never have which character out of all three. So for this one the basis don't change. So for this one, like, you will get x, y and z. So it's for here, let's say it is x. So it is 1. You will get it x, right? So here the basis is symmetric with respect to that symmetric operation. Basically, this is your this was your, as I told, some transformation matrix, or this is your operator, or this is your operation. So this these are, so for this the basis is symmetric. These bases are symmetric, means that these are not changing by operating this operation on these bases, on these bases. And for minus 1, your basis will become like negative. So so your basis will be, basis is antisymmetric with respect to that symmetric operation. And for 0, if this is your operation on, let's say this, your basis will become 0. So I think this is your answer. So this cannot be, never be a character for 1D representation. Okay. But also this is your imaginary operation, which is equal to minus 1 minus, let's say this. Okay, so this will transform your basis to imaginary basis. This will transform your basis to imaginary basis, which is also not possible. So I think these two are answered, but the question is saying one dimensional representative can never have character with value of. So it is multiple select question or multiple? Okay, answer is CD. So third one, C and D cannot be the character of one dimensional representation. So is it okay to you guys? Patlekha and Shivam. Okay, both of you are saying yes. Okay. So moving to next question. A two-dimensional representation means x1, y1, let's say x2, y2. The two-dimensional representation may have a character value of. So these all are possible, I think. This. But imaginary is not possible. But here 0 is possible because it is 1, 0, 0, 1. So this is like identity, two-dimensional identity matrix. So 0, 1, or you can say minus 1. So it is possible, all of them, all A, B, C. But this imaginary cannot, because it will change your basis to imaginary basis. So that is why. Okay. So is it okay to you? It is not possible because let's say if this is a matrix 1, 0, 0, minus 1, then whatever basis you will get, these bases will be imaginary. So that is the thing. Okay, moving to next question. So next question is for reducible representation. For reducible representation, Mulliken nomenclature is. So this I think is easy, but so you know that for these Mulliken symbol, E comes like A and V, both represented by 1, 1, but E will be represented by 2 for Mulliken symbol. And if it is so let's say take this one C2Z. The representation, a reducible representation for C2Z is 1, which means the symmetric, this operation is symmetric to the bases, so which will represent A. And for this C2, this is also 1. This is also symmetric, right? So the Mulliken symbol will be 1. So for symmetric, it is 1. For anti-symmetric, it is -1. -1 or 2? 2. It is 2, sorry. So we got from here, this is A1. And E is representing here, this E is 1, which means your this order, this E is the representation for E is 1, which means that your Mulliken symbol can be A or B or B or B, because they represent this A or B. So I think your answer should be A1. And for this, we also write these Mulliken symbol if I is present by gerade, G, or ungerade. And for sigma H, if it is symmetric, then it represents 1, and if it is anti-symmetric, then 2. So if you remember this, you will be able to solve this. So are you able to follow, guys? These are Mulliken symbols, A and B. Okay, so moving to next question. Okay, moving to next question. So next to 7 question is, for the reducible representation, Mulliken nomenclature is. So again they are asking for the question is asking for the Mulliken symbol. So here now the irreducible representation E is 2. So which means as I have already told, A, B and E. 1, 1, this is 2. Multiple symbol will be E. Yes. As you can see from all of the options, it is E, E1, E2, E, only E. Something is okay. Maybe misprinted. This should be E1 or E2 dash, because the dash will come after this E2, E1, the subscript. After then the superscript will come. So there is a misprint in option C and D. Okay, we will solve anyways, so we'll get to know the answer. So which means that it is two-dimensional. E2 means if these two are, then it is means the irreducible representation is two-dimensional, and if one is present means that it is one-dimensional. The representation, irreducible representation. So as I can see, if this is your, here we have why we have taken this C2 and this C2 and C2 dash, because this was our principal axis of symmetry. This C2 Z, principal axis of symmetry. Again, for this question, next question, we have also have to take care of, first take the principal axis of symmetry. Okay, so what is principal axis of symmetry in this irreducible representation? Try to find it out and tell me, both of you, Patlika and Shivam. What is principal axis of rotation here in this irreducible representation? S S4 S4 is not present. I think my screen is not visible. Okay, okay, got it. So for question number 6, principal axis of symmetry is C to Z, and here for this question number 7, what will be the principal axis of symmetry? C3, yes, it is C3. This is a principal axis of symmetry. So here, after operating uh, after this, after operating C3, the representation is minus, which means that the E, so 1 for symmetry and 2 for anti-symmetry, which I have already told here, this symmetric and anti-symmetric. Okay, 1 and 2. So This is -1, which means it is antisymmetric. So E2 will come. So that is why I am saying that something is wrong here. So some subscript should be there. So which means that this answer cannot possible. E1. Okay, this got eliminated. I don't know, because now we cannot eliminate the answer because answer is also misprinted here. So anyway, we will find out. Then then okay, then sigma h. This sigma h. What is it? It is positive. Okay. So this is symmetric. And this one for this is for symmetric and this symmetric. Okay. So this should be the, so I think if, so this should be the answer, I guess. So here I don't know, E dash, only one E dash I am able to see, so this should be maybe it is misprinted. So E1 2 is E dash, E2 dash. This should be the answer. Okay, maybe in the next session I will look up to this and tell you. The answer is also given C. So maybe it is misprinted. Anyways, okay. Moving to this question, consult a character table of tetrahedral point group. For this group, we have an reducible representation. Okay, screen is not changing. Okay, okay. Okay, now I think it is question number 8. Okay. So the is left the meeting. Okay. Anyways, now they are asking for, the question is asking for consult a character table of tetrahedral point group. For this group, we have a reducible representation. They are asking for, the question is asking for the reducible representation. So we know this formula A1 1H. What is H? H is order. Okay. So this is the contribution of a particular irreducible representation in the given reducible representation. So okay, tell me what is H here? What is H here? Order is, I have already told. So tell me the number. What is order? 24, yes. S is 24. But we need our corrector table, tetrahedral corrector table. Hmm. Okay, so we need corrector table. This is C4B. Don't have corrector table of tetrahedral. C4B. 4B. Wait. This is the corrector table, okay? Okay. Okay. So as we have already here I pasted. Oh. Hmm. So to find these, you have to solve like for A11, A1, 1y24, 24 is your order. Then this multiplied by this. One 15 1 So how this is coming? The 15 is your this. 15 is 0, minus 1, minus 1, minus 1, 3. 15, 0, minus 1, minus 1, 3. And this is for A1, 1, 1, 1, 1, 1. So this is 1, 1, 1, 1, 1. And how many times this is repeating? E1, 8, 3, 6, 6. So 1, 8, 3, 6, 6. Now we have to solve it. So 15 minus 3 plus 6 plus 18 divided by 24 equal to 1. So A1. For A2, so again we have to change only this 1, 1, 1 minus 1. Okay. So 1, 15, 1 plus 8, 0, 1 plus 3 minus 1, 1 plus 6 minus 1, minus 1, minus 1, minus 1, then 6, 3, minus 1. 15, 0, minus 3 minus plus 6 minus 18. Plus. So 15 plus 6 minus 3 minus 18. This is 21, 21, 0 by 24. Okay, 0. Similarly for AE, 24 by 24 equal to 1. If you solve it, you will get it like that. Okay. And for AT1, 24 by 24, 1. Then AT2, 72 by 24 equal to 3. So what will be your reducible representation? This should be A1 plus A2 is 0, E T1 plus 3 T2, 3 T2, 1, 1, 0, 1. So this is what they have. The question is asked. We have a reducible representation. So 3T2, A1, E. A2 is not here and A2 is not present. I think option A is correct. So are you guys able to follow? If yes, then we can move forward. Otherwise, we have to discuss it again. Patlika saying yes, sir. Okay. Shivam is also saying yes. Fine then. Let's move to next question. So screen is okay. Fine. Internet is slow, I think. Hmm. Oh. Okay, so the next question is partial character table of C4 weak point group is provided below. So here they have provided the character table. Using this character table without referring to any other resources, symmetry of Z is basically they are asking for Mulkan symbol. So I should okay, try to solve it from your side. So partial character for C4 point group is provided using this character table without referring to any other symmetry of Z is. So basically this, if it is not visible, then I can say E to C4 Z, then C2, then 2 sigma V, 2 sigma D. So let's say this is your, these are your axes, X, Y and Z, right? And your principal axis is along the Z direction, C4 Z. So E will give you 1, nothing will change. If you apply C4 along Z direction, C4 means like this is, so C4 if you rotate it by 90, it will be like this. Okay, so C4Z is also 1. Your axis have rotated, if you consider your basis is Cartesian coordinate, then they have not become plus to negative. So that is why this is 1. And for C2 along Z direction, C2 will be like x, z equal to 1. Next is sigma v and sigma d. Consider this yz or xz. You will get 1 only. So I think it is matching with your A1. So fully symmetric it is, total symmetric. So answer should be A1. C2 C2 is also along the z direction. So if you it will be like this. This is happening, right? Your z is remaining z. So they have asked the symmetry of z is. So it will z will remain 1. So that is why these all are 1 1 1. So that is why the answer is A. Is it okay? Okay, sir. Okay, moving to next question. Next question is using the character table provided in the question number 9. This character table C4D without referring to any other sources, symmetry of RZ. So basically they have not provided these linear rotational whatever he has these linear rotational quadratic. So that is why they are asking what is happening. Anyway, so symmetry of RZ. This is RZ. So R is rotation along Z axis. So let's see. Try to see one by one. Okay. Let's see if you rotating this way. This is anti-clockwise. Anti-clockwise. So anyway, E will give you 1. This E. E. Yeah. This E operation will give you always 1. Next, what is it? 2C4X Z means C4Z. So what will happen for C4Z? By rotating it along the Z direction. Z will remain Z. It will not going to change, right? These will change. Let's say if 90 degree, so 90 degree will be like this side, no, this and this, Y, X and Z, but Z will remain Z. So 1. Next, what is the operation? C2. C2 is also along the z direction. What will happen? It will rotate your. It will be like C2. So this is X, Y, Z. So Z is Z. That is not changing, right? They are asking symmetry of RZ. Next, what is the operation? Sigma V. Sigma V. Sigma V means it is not perpendicular to your axis of rotation. It is containing the axis of rotation, which means your Z will not going to change. Is it okay, guys? Till here, are you guys able to understand? Okay, okay. I think this is wrong because sigma V is, if you consider any sigma V, Y, X, Y, Z. Let's say I'm taking different color. This is your sigma YZ. Sigma YZ will reflect. And then you are rotating clockwise or anti-clockwise. I think it will give you minus. Sigma V. Next is sigma D. Sigma D is also give you minus. So if this is the case, then 1 minus 1 minus 1 E C4 C2 sigma V sigma D. Let's say which symbol is here. 2 minus A2. A2. So answer should be C. Is it okay? So let's check the answer. Yes, you are correct. Okay, we are almost, not almost, we are done for assign. We have finished assignment 6. Okay, my screen is like this. Okay, fine. So we have spent around 1 hour for assignment 6 to solve assignment 6. Now it's time to solve assignment number 7. This is like pure calculation. So if you are able to solve one question, you will finish all the questions if you get the idea. So all questions are same in this assignment. I think in this assignment there are 10, 8, okay, 8 questions are there in this assignment. And all of them are more or less same. So we will spend our time on uh, first two questions and explain. Then we will speed up. Okay. So first question is here we okay. First question is the isometric stretching modes of H2A is shown below. The molecular plane YZ and the symmetry axis of H2O is Z. The vibration transform as the irreducible representation. We need character table, I think, for this to solve this question. So let's draw first. Like this is a H2O. Hmm. This question is saying it is asymmetrical stretching. This, and this is going. So let's find out the character table of this. We need character table. Okay. I think it is not visible. Now it is visible. C2x. Next, these are your coordinates x, y, and z. So for E, C2, and sigma v, these are your operations. So what will happen? Let's see. For E, it is 1. For this asymmetric stretching, for E is 1 obviously, and C2. C2 is, this is your C2 along x. So after applying this C2, what will happen? This will happen. So this stretching will be here. This will be here. So it is -1, right? It is not similar. If this becomes, then after C2 operation, C2x, it will be like, right? So it is -1. It is not symmetric because it is not symmetric orientation, equivalent orientation. It is asymmetric stretching because that is why this is -1. And for also sigma v will also contain this C2v, so it is like this will reflect these two hydrogen atom exchange, so it will be -1. So one, if this is your plane, and if if the plane is this, in which this hydrogen this water molecule is present, so it will not going to change. It will give, this is xz. If sigma v yz should be 1. Internet is slow. ठीक है. Please reply guys, otherwise I will end this session. So B2, it is matching with your B2. So the vibrational transformation as a irreducible representation. It should be answer B2. Okay. Question number 2 is, using character table and standard formulae, assign the IR active mode for ammonia. Ammonia character, we need character table. Let's first draw ammonia. Okay. The point group of this is C3V ammonia. So we need to find the point table of character table of okay. So we need to find the IR active mode, not the normal vibrational mode. So C3 we have operations E, C2 and sigma V. This is this is table of C2V. C3V. Okay. C3V sigma V. So using the character table in standard working formula, assign the IR active mode. So let's find out. So first we need to find out number of unchanged atoms. So for E, all the four atoms will remain in their position, and for C3 axis, how many? Tell me how many atoms will remain unchanged? One, yes, one. And for sigma V, how many atoms will remain unchanged if you apply sigma V operation? 2, yes. So character for E is 3, for C3 it is 0, and for sigma V it is 1. So this 3n reducible representation will be 12, 0, because it is multiplication of these two, character and number of atoms unchanged, and 2. I'll tell you the trick about these, how to determine this character, or let's see, you can find it out here also. So Z and XY 2 plus 1 3, and for C3 -1 plus 1 0. For sigma V 0 plus 1, so plus 1. Okay. Now try to find out the, so here order is 6, as you can see 3, 2 and 1. Total is 6. 1, +6, 3. And for A2 it is 1 by 6, 1 plus 1 12, it is 1. Next is E. Next is E. 1 by 6, 1, 2, Tn 3A plus A2 plus 4E. 4E, 1A2, 3A1. Now try to find out these XYZ, the rotation translation, or I would say translation. So translation for it is A1 and E, Z and XY, A1, E, and for rotational it is A2. Here should be this RXY or Y. So for rotational A2 plus E. So after subtracting from this, this is your T vibrational, sigma vibration. So total is 2. And for ammonia, if you try to find out the vibrational mode, it will be 3n minus 6. So 3 into 5 minus 6, 4 is equal to 6. So if you try to find out 2 into 1 plus 2 into 2 equal to 6. So our answer is correct. Whatever modes we have got, these are normal modes. Now they have asked for normal vibrational mode. Normal vibration mode. Now they have asked for assign the IR active mode for ammonia. So IR active will be this Z and E. So these are your IR active mode. So actually in this these normal vibration mode these are all IR active. Whenever this the symbol assigned for this, if the linear function is there, linear function here x, x, y and z, so if this corresponds to your IR active modes, and if they are quadratic, then they are Raman active. So they are IR active. And also if you see A1 and E, here quadratic is also present. So these two modes, all these six are Raman active also. So for IR it should be X, Y, Z, like linear. And for Raman it is quadratic. Quadratic. Okay. If also someone asks you the parallel these parallel modes and perpendicular modes, then how we can determine these modes? So for parallel mode, it should be symmetric with respect to your principal axis. So let's say this was your x, y, and z. This was your z, C3. So that is why this z, this is your parallel mode, and the x, y will change their position. So that is why they are perpendicular modes, because these are symmetric to your symmetric to principal axis. These are perpendicular to your these perpendicular modes are asymmetric with respect to your principal axis. Okay, fine. Let's move to next question. So next question is the number of IR active vibrational modes of CO2 is. So they have not asked the normal modes. They are question is asking the IR active mode of CO2. CO2 3 to 3 minus 5, 9 minus 5 equal to 4. So these are your normal modes of vibration. Right. And the IR active, so we know that this is symmetric, right? Symmetric stretching. So no change in the dipole. If there is no change in the dipole, this is IR inactive. Other modes are other will be like this. So this is dipole is changed. This is IR active. And for bend like this is going here, here, and this. This is going. C is going inside the plane or out of the plane. So these are bending modes. These two are stretching mode. So total vibration mode are 4. 1, 2, 3, and 4. But these two bending mode, these are also the dipole will change. So IR active. So out of 4, 3 are IR active. So the frequency of this is 667 centimeter inverse of these bending modes, and this IR mode is 2349 centimeter inverse. So these will be IR active. So answer will be 3. And for this it is 1340. But if anyone asks about how many bands you can see in the spectra, it will be 2 only, because these two are coming at the same wave frequency. Is it okay? Okay, moving to next question. So the normal modes of vibration. Normal modes of vibration for hexafluorochloroplatinate. So basically we need character table of octahedral. Okay, leave this question because this is too lengthy. So it is easy, but Okay, now, okay, let me solve it. Okay, we will solve in the next class. Okay, try to solve these. Try to find the point group of D. Yes, it is C2. Okay, find the point group of E. Yes, it is C2V. Next, point group of this F molecule. Oh, this is C2. Okay, what is the point group of molecule Z? C1, yes. Okay, let's move to this question and finish this. Sigma D, 6 sigma D. Okay, so number of atom not changing, right? So for E, there are 7 atoms which will not going to change. Okay, for C3, it is 0. X, Y, Z, all of them are here. So C3 is 0. C2 is -1. C2. No, this is for corrector, sorry. This is for corrector. Okay. So for C2, okay, try to tell me how many number of atom will not change if you apply C2 in this molecule. There are questions left, but C2, this is octahedral. No, C2 for 1. Yes, because like this, yes, C2. Other C2 will be also, because if you take this C2, then 3 molecule. 3 atom will not change its position. However, if the C2 is this, then let's say this is for 1, and for CH, C4, it's 3, and for C2 is 3, I for 1, 1, 1, 5, and 3. And for For C3 it will be 1. Katrika is saying for C3 it will be 1. Yes, platinum. Okay, yes, of course. So I think you have understood. Okay. Then corrector, you can determine this. So E is 3. X, Y, Z are all are here. So E is 3. Basically this line you can just write it down. 0, -1, 1, -1, 3, -1, 0, 1, 0, 1, 1. Okay. So your representation for this will be multiplication of these two. 21, 0, -1, 3, -3, -3, -1, 0, 5, 3. So question is, if you look closely, question is saying, this is long question because there are a lot of Mulkan symbol. So if you try to solve each one of them, it will take around 20 minutes, but I can tell you is that you can solve for A1G. If it is there, then these three is the possible answer. This will get eliminated. So let's solve for A1G. This is your reducible representation. Reducible, where is 21? This is your reducible representation. 1 is your irreducible representation, and this is your corrector, C. Okay. So 6 minus 1, 1 plus 6, 3, 3, 1 plus 3 minus 3, 1 plus 1 minus 3, 1 plus 6 minus 1, 1 plus 3, 5, 1 plus 6, 1. It will be 48 by 48 equal to 1. 48, how it is 48? You can add 1, 8, 9, 6, 15, 21, 23, 25, 31, 39 and 9, 48. So H is 48. So it will be 1, which means this option got eliminated, right? Normal mode of vibration for this molecule. Similarly, if you, what is not common here? See, A2Z is not present here. So here, so we don't have to solve for A2Z. Next, come for EZ. So for EZ, if you solve 1 by 48, and if you do all these, it will be 48 by 48, so it actually will get 1. So EG, in that your whatever you will get 1G plus EZ 1 plus whatever you will get 1 EZ. So in the option If you look closely, only this option is having one easy. So this will be your answer. Otherwise, you will keep on solving for each of them. It will take time. So, which is the trick to actually solve the question. Okay, I think, okay, Shivam is saying fine, sir. And what about Pathalika? Okay, fine. And for this question, partial character table of C4V point group is provided below. So using this character table without referring to any other sources, symmetry of Z is, this we have already solved, I think, this question. C4V, for C4V, right? X, Y, this is Z, Z. So if you apply E, it will give you 1. C4 along the Z direction, it will give you 1. C2 along the Z direction will give you, Z will not going to change. And sigma V, it will be 1. So I think answer will be, I think we have solved today only. C4V, this one only, no? Same question. Answer is A1. So answer is same, yes. Okay, moving on to next question. Using the character table and standard organ formulae, work out the symmetry of normal modes of vibration for pyridine. Okay, they are not asking for IR active, normal mode. One thing you can do is try to pyridine. Okay, first. The total number of atom here is total number of atom here is 11. So 3n minus 6 equal to 27. Total number of normal modes of vibration. But these are multiple choice questions, so you can also calculate this. That this is not possible because A1 is 1 and B1 1 into 1 plus 1 into V is also comes for 1, 1 is 1. So this will give 3. So here we are getting total 27. They have asked normal. So this cannot be the answer. So because I have already told A and V is 1, E is 2. And here only one A1 is present, one V1, one V2. So that is why 1, 1, 1, 1, 1 into 1, 1 into 1. So 3. This also, for this also, it is 2 into 1 plus 1 equal to 3. This cannot be the answer. I am just telling the trick, otherwise you can solve it by using the character table, which we have already solved. Like using the character table, the same way we have solved these questions, these questions. So for this, the character, so for this, I think the point group of this will be, what will be the point group of this molecule? Tell me. So here it is C2B point group. So using the C2B point group character table, you can solve it. Or for this one also, 2 into 1 plus 1 plus 2 into 1. So 2 equal to 5. Cannot be the answer. So this will be your answer. This is the trick. Because they have not asked, the question is not asking about the higher active mode. They are asking about the normal modes. That is why. I mean the total mode. So 27. So let's calculate for this also. 10 into 1 plus 3 into 1 plus 9 into 1 plus 5 into 1 is equal to 10 plus 3 plus 9 plus 5 is equal to 13 plus 9, 9, 5, 14. It is 27. So this is the answer. Fine. Otherwise you have to uh, solve this using character table, find out the number of unchanged atom, then character, then a reducible representation. Then reducible representation like this. Okay. Then you can solve for each of them. Then you can find out the total number of modes, translational, rotational. Then you can then you can subtract. No, I mean total number of modes. Then you can subtract the translational and rotational by looking at the character table. These are your rotational. These are your translation. So minus these, you will get the vibrational mode. Okay, and out of them, if they are whatever total number of normal modes you'll get, out of these, if you get the these modes are having um, this quadratic and linear, according to them you can say that these are higher active, higher not active, Raman active, like this. Here we have, so if they are linear, just like this. If you are getting like if you solve, you'll get this total number of mode, out of which you can subtract these translation and rotation. How? This is rotational, these two are translation. So if you subtract these two and rotation, for this rotation is this and this, then you'll get vibration. Out of these vibration, out of these vibration modes, you can determine these are higher active or not. So if they are linear, they are higher active. So this and this are higher active. So similarly, you can calculate for this question also. But here just I have calculated. Okay, you are not able to question. Yeah, for this question. Otherwise, you can solve it. And this is the trick you can use. Okay, moving to next question. Using character table and standard operator formula, work out the symmetry operation of they are again asked about the normal modes of vibration of. Okay, this question is same. Question number 2, similar to question number 2. Using the character table of standard operator, we assign the higher active mode for ammonia. They have question number 2 is asking for higher active, and question number 7 is asking for normal. Okay, total modes of vibration. Total. This we have. Okay, so for this question number 2, total T. This is your these are your total normal vibrational mode. So total we have found 6. 2 2a1 plus 2e. Okay. 2a1 plus 2e. This is your answer, I think. Okay. Yes. Is it okay, guys? Got it. Okay, fine, sir. Fine, sir. Okay. Okay, moving on to the next question, and then assignment and 8 will begin. So this is our last example, the last question of today's session. Okay, using the character table in standard working formula, work out the symmetry of normal modes. Again, normal modes of vibration of boron trifluoride. Boron trifluoride. So how many atoms? Total 4 atoms. So 3 into 4 minus 6 will be 6. Total vibrational modes, right? You can calculate it also. So you can eliminate the answer by looking this. 2 into 1 plus E represent 2 plus 1 is equal to 5, right? So this is not the answer. Option A is not the answer. B, 1 plus 2 into 2 plus 1. So 4, 6 can be the answer. C, 3 into 1 plus 2 into 2 plus 1. So 4, 4, 8. This is also not possible, right? Because they have asked normal mode, I mean the total vibrational mode. So total vibrational mode we can determine by using this formula, 3n minus 6 equal to total vibrational mode. So according to this formula we are getting 6. So total 6 should be the okay total vibrational mode. For D, 2 into 1 plus 2 plus 2 into 1. So 6. This so B and D can be the answer. This is just to solve quickly. You can determine. Okay, now we actually have to solve this. This is simple, but let's solve it. Last. So tell me, what is the point group of this BF3? DS3, yes, DS3, because C3 is present and C3 is perpendicular to C2, and these are in the plane. So sigma h is also present. So D3H. Okay. Now this is the character table for D3H point group. So for D3H, C3, C2, sigma H, S3, sigma B. So number of atom not changing. Okay, E is also left. Okay, E. So for E, number of atom for BF3, 4. Okay, and for C3, C3, you rotate this from the only boron will remain there. Will be 1. C2, 2. Sigma H, 4, because molecule in the plane, and S3 only boron will remain there, and for sigma B it is 2. Then character you can determine by multiply E for this and this, C 2 and 3. So this is 3 for C2 dash. Sorry, this is for this. For C3 0, C2 dash -1, sigma H 1 -2, addition 1. So tau 3n will be 1 -2, 4 -2, 2, 12. Now you can solve and solve according to the options. See which one is, all of them are common. A1E, A2, A1E, A2. Okay. So let's solve any one of A1. Let's say A1, if you are getting 2 A1, then this answer is correct. If you are getting 1 A1, then this answer is correct. That's it. So for A1, what is the H? 1, 2, 3, 6, 7, 9, 12. So 1, 12, 1 plus 3 minus 2, 1 plus 4 plus 1. So it will be like 12 by 12. So it will be 1, which means this is your correct answer. Okay. So I think it's time. Time is over. It's time to. So let's finish our class here. And in the next class, we will solve assignment number 8 and 9. Okay. Please join next Sunday 4 p.m. Thank you.